Similar to how we had overloaded functions to create a variety of them, we can actually overload operators in C++. Now what is the reason for doing so? The reason for doing so is the familiarity with the various operators which are there. So if I am able to use the operator equal to between two objects, I intuitively understand that I want the objects to be compared as being equal. Now if I can use the plus operator between two objects, it intuitively means that I want to do an addition operation. So the convenience of using the same operators is one reason why this is so important. Another reason is that I do not necessarily need to worry about the individual objects, rather I can just mix and match them. And this becomes all the more important once you are working on a very large software system. So here we have an example of this particular operator overloading. So what we have done here is created two objects of the CFRAC class. In the first case we assign it a value 2 by 1 and the second case 3 by 1. Now what we can do with the overloaded operator equal to is, then I can use it in a if conditional like if temp1 double equal to temp2 and just see out if they match or they do not match. Now since the particular operator has been overloaded, this is going to work just fine. And that is what is being shown here as the output of this particular program. Right? It actually prints they do not match, and then there are two calls to the destructor. So here is an example of overloading the unary operator plus plus. And note that there is a common signature of any unary operator, and that is class name as a reference, and this will be the return type, operator, operator name, and parenthesis. So we see the signature in case of CFRAC as CFRAC ampersand operator plus plus, means this particular operator is going to return a reference to the object. We again have a definition for this as CFRAC ampersand CFRAC colon colon operator plus plus, and then what we do is we do a val plus equal to 1 and then return the this pointer, because that is what we are operating on. So there is a reason why it needs to return a value, because you could use it in other expressions, so the return type has to be the same object. So we create an object temp1 2, 1 and then we are easily able to do a plus plus temp1 on that. And we have not shown here the output of this due to paucity of space, but it is just going to increment the value of the numerator by 1. In this case it will become 3. So here is an example of overloading the binary operator plus. The common signature for all the binary operators is that we return a copy of the object on which it is operating, and then it basically takes in as another argument the other object on which it needs to act. The copy is important because it will be a locally created object which will actually be returned, so a reference to it cannot be returned, since it will get destroyed the moment the function ends. A concrete example is shown here with CFRAC. We have an operator plus, and which takes in a reference of CFRAC, which is the RHS as we have named it, and it returns a CFRAC object. The definition of this is shown on the CPP file screenshot. It simply creates a new object CFRAC and then does a this getVal plus RHS got getVal. That is it, adds the two of them. In the main routine, we create a new CFRAC temp3 is equal to temp1 plus temp2, and we could do this because we have a copy constructor here, and then we simply print out the value of temp3. What this is going to do is it will actually print out the value 5, because that is what these two numbers will add up to. One thing that we had implicitly done in the previous slide, wherein we introduced the overloading of binary operator, was we had lots of implicit copies. Now it is important to highlight this point, because what happens is that this is not so obvious once you start using these objects in complicated expressions. So we have a simple example here, which is using the same plus binary operator that we had defined in the previous slide. Just that what we do is now temp3 is actually constructed using a sum of 4 different objects. So let's see what happens once we run this. Since we have a printf in the destructor, we can actually see the output on the right. So we see 2 calls to the destructor because these were some local objects which were created and then immediately destroyed. And then we get a printf. So once we get a printf, after that the 3 temp1, temp2 and temp3 are destroyed. So we actually have a 3 destructor calls there. So in this case, what we did was we actually silently introduced 2 copy operations in the assignment statement. Temp3 is equal to temp1 plus temp1 plus temp2 plus temp2. So this is something which we must be careful about, and if we are using such overloaded operators, especially plus, minus and other such binary operators which are quite frequently used, we must be aware that they are going to introduce overheads. So it's a good idea not to use them in complicated expressions. And if your program is performance sensitive, especially if this particular operations are being done in a performance sensitive part of the program, maybe you want to provide another mechanism which is much more efficient.